Hi, I've been really excited about bringing this video to you. This is one of the most exciting things I think I've yet been able to actually do with a Pico-W, and that's to update that firmware over the air. So actually putting on new code onto the firmware, getting it running, all coming straight across the internet. This is fabulous, and this is thanks to some great work done by another guy, Jakub. Jakub's written the bootloader to actually handle over-the-air updates, which is brilliant. Now, of course, there's still quite a lot of work for application developers like me to do to actually look at how we're actually going to pull data across the internet, how we're going to actually store that, manage that, and all of that piece. But the bootloader, the new memory model that needs to be placed on that Pico-W, that's what Jakub's done, and a fabulous job he's done of it. So that's what I want to share with you today. Please do like the video and please subscribe. I really do appreciate it, and we get straight to the code. So I'm going to demonstrate this over-the-air update, yet very unimaginatively using an application called Blue, which is basically just going to flash a blue LED for 20 seconds. It's then going to download a new firmware, which is going to be a green release or a green application. And it's going to do that over HTTP GET, so a web protocol. And then it's going to trigger an update of the firmware. And that will result in the green application running. Green, of course, is then going to flash an LED, and it's going to flash a green LED this time. And it's then going to download a new firmware, which is going to be the blue release. And it's doing that over HTTP, and then it's going to update. So you can see we're actually going to switch back between two very similar applications, but they are completely separate applications and completely separate firmware as far as the Pico-W is concerned, that it is downloading and then executing. So here we have the green application running, and you can see the green release identified there, and it's flashing the green LED. And then it starts updating, and it downloads 44 chunks of the blue application. And it's then going to go through the updating of firmware so that it can reboot itself. And here it's up with the release blue. And in a couple of seconds, as it connects to the Wi-Fi, it will start flashing the blue LED. And it will keep flashing that blue LED for 20 seconds before it will do 3 very quick flashes and starting the process of downloading the green firmware application. So there you go, you can see all the chunks of the green coming down, and it goes through that process of updating itself, ready to run that green application. There we go, green firmware release is up and running. I couldn't bring these videos to you without help from my sponsors, and this video is sponsored by PCBWay. Now, we all think about PCBWay as the easy way of getting our PCB prototypes built for us, helping me get PCBs fabricated and giving me design advice. But PCBWay do so much more, whether it is that community of shared projects that we can go and inspired from, whether it is their other services of 3D printing or sheet metal fabrication, CNC, etc. Or is it their new module shop where I can go and buy new exciting modules to play with on the back of my Picos? Go check out PCBWay and use them to inspire your next project. As always, all of the code for the project today is available on GitHub and available to share. So this project's really broken down into 3 bits. Blink, just blinking an LED. The HTTP GET to actually pull down that firmware. And then the bootloader itself. So let's have a look first at the bootloader. And this is Jakub's work. And this is really what enables the whole of this OTA piece to work. So he's redefined the memory map. So at position X 1 million, you can see the normal start position for our application. That's now the start position for that bootloader. So this has now moved so that the application sits in now a number of application slots or download slots, and the bootloader handles the jiggling between whether you are updating from a downloaded new firmware and placing that into your application slots ready to run. So this is really the new memory model, but this is all nicely handled for us by that bootloader code. In fact, Jakub's done such a great job that he's actually placed all of the build stuff for us. So we can just download this Pico Photo bootloader module into our project and include it in our makefile, and that will then have all of the additional configuration required to tell the linker to build a new different memory model and memory layout, as well as build the bootloader itself. So that's really easy. It works straight out of the box, no problem at all. Even the way that I had to manipulate it a little bit for this project, so I could build two binaries from basically one set of source. To use a bootloader, really we're actually only doing a few things. We're initializing the bootloader slot, which is basically freeing up flash so that we can write to it. Then we write in segments, must be at least 256 bytes, and in fact in exact copies of 256. This is a restriction placed by the Pico's flash and how the Pico flash works. And so we write the segments of our application in, and then we can mark that application as valid, and then we tell it to do an update and perform a reboot and an update on the Pico. So that's all there is really to the bootloader and working with our bootloader. The website of this, the actual download of the firmware, well, that's another story. So of course we're going to use the CYW43 driver because we need Wi-Fi available to us. We also need LWIP to give us Wi-Fi and IP over Wi-Fi. And then I'm going to use a couple of FreeRTOS packages to help me do some of the more complicated HTTP parts. Firstly, I'm going to use my friend the FreeRTOS kernel because actually I find IP and TCP/IP much easier to handle when I've got a bunch of tasks looking after pieces of that for me. And then I'm going to also use HTTP core, which actually gives me the whole HTTP protocol so that I can initiate an HTTP GET and get the response back, and that will be handled for me by that library. And on top of that, I'm going to write my blue and green applications. Actually, they're just going to basically be one application that I'm just shining in some definitions to tell it to flash a different LED and give the application a different name. But, you know, the point is to demonstrate actually there are two true binaries here. Of course, when we download our firmware, we're not going to be able to download it in one chunk. You've already seen me download it in 10K chunks. That's because the firmware is quite big, and in fact it's bigger than the Pico's memory by quite some way. So I'm going to download it in 10K chunks, and I'm going to do each chunk as a separate HTTP GET. Now the reason for that is that when I go out and update a segment of the firmware, I know that that's going to be writing to flash, and I know that that's going to halt everything else going on the core of the Pico. In fact, it will actually have to halt everything going on two cores, so that there is no flash operations going on while the flash is being updated. Now, that means that there is no code there making sure that we are holding and keeping alive the TCP/IP connection, that we're handling any data that's arriving or anything like that. So there is a huge risk that we could lose data. And as I'm not doing any CRC checking or validation of what I'm downloading, I'm just assuming everything I've got is correct, this would be really quite dangerous with the firmware. So I thought it was safer to actually do it as 10K separate HTTP GETs. To do that, I've got a little Python bit of code which is acting as my server, and it's running the Flask library. And I'm actually, when I'm issuing a GET, I'm telling it how big the segment size I want it to deliver is and which segment number I want it to give me. And that's how I'm downloading those 10K chunks of the firmware. Now, Why is that firmware so big? As you see, my firmware for this is 412K, which seems incredibly large. Well, perhaps incredibly large is an overstatement. It seems larger than I thought would it be. I was expecting 200 to 300K. But actually it is quite large, and the reason it's large is that W43439A0 object you see there. That's 53% of my binary size. Yeah, that's quite big, isn't it? What is that? Well, that is the firmware itself for the CY43 Wi-Fi module. Although that module has ROM that it's presumably running some of the code in order to manage Wi-Fi from, it also requires a set of firmware data to be updated every time our Pico-W runs up. And that's what that is. And it's massive. And for OTA stuff, that is a bit of a problem. But hey, it works. We can download this. We've demonstrated it works. But yeah, that came as a bit of a surprise as I was working through this code and how this works. Let's have a look at the project in the repo. So here in VS Code, we've got my repo, and I guess the place to start, let's have a quick look at server. So server is the very simple Python Flask server that's going to provide the firmware when requested. And so you see here we've got the green request, and it's checking for a segment size and segment number as attributes on that HTTP GET request, and it uses then to send a chunk of the file. And I've got a little utility down here that's just going to read through the file, find the right bit, do an MD5 hash of it, because I just wanted in testing to confirm MD5s are okay. So there are lots of MD5 calculations in the code I'm going to show you. They're not actually doing any system-wide testing. They were just me eyeballing that the data I'm sending from Flask is the data I'm receiving on the Pico, both at the segment level and at the total level. So we're basically moving through this file using seek. We're finding the right bit of the file we want. We're grabbing this buffer size and we're sending that over. So that's what server's doing, and it's got two targets in there. We have blue and green to get the two firmware versions. The rest of the code really is under blue, with the exception of the library and the port code, which are shared. Port is the configuration of the libraries that we're using, so I need to do a little bit of configuration for core HTTP, FreeRTOS kernel and LWIP for the application. They're all sitting up at this level and shared between the two projects. The libraries, again, they're sitting up this level. They're shared between the projects. A little bit more libraries I'm using than perhaps I technically need. You see MD5 there. I've also got a couple of JSON pieces there. I'm not really using them, but one of the pieces of code I was using previously to do some web services traffic, I actually have reused in this project for speed, just to get stuff up and running. So I've put them there because they're dependencies. So everything else is in the blue version of the project. And you can see here we've got the Pico-Photo bootloader. So this is a submodule within the project, and that's just all added in from Jakub's GitHub repo himself. So and that all sits in there. And you can see we've got the include files to give us the definitions for working with this firmware and rebooting and updating. And we've also got the linker configuration files. Won't be at all surprising that we're including in our makefile this Pico-Photo bootloader. Then in the source folder we've got a couple more configurations we need to do to get all of this to build. Not only do we need to link our target with the Pico firmware OTA bootloader, but we also need to do a couple more options here around link options and a linker script, and those are what adjusts the memory model on the target we're building so that it will support this new memory model and will allow us to do that firmware load. I'm cheating here in some ways because I've really just written one application. I've just happened to be using some definitions to change a few things, like what the release number is, what the URL is, and which GPIO pad we're using for the LED. And those are all set in here. Oh, and in case you're wondering and you try this and it doesn't quite work as you expect, I'm outputting my standard I/O as UART over pins 16 and 17, as I often do on my projects, because it makes it closer to the SWD port and my wiring's a bit neater. That's the reason I tend to do that. Cool, so let's have a look at the main code, which is really where all of the work goes on. And this is a FreeRTOS kernel application, so you will see that I am launching up some tasks, a main thread task, and I'm starting the scheduler. So really all the code here for what we're talking about is done within my main task. So my main task is going to check to see if the firmware has been updated. If it is, it will tell me the nice message to say we're running new firmware. It's also going to print out the release that we're running so that we can see which release this firmware is every time it boots. We're then going to do all the Wi-Fi setup piece, and then we're going to go into running Blink for 20 seconds. Once that Blink's confirmed and completed, we will actually do the OAT download and update. So really all the code for doing this over-the-air update is in this OTA update function. So let's have a quick look at that. What we're going to do is we're going to malloc some buffer space, and we're going to grab a 10k buffer, well actually a bit bigger, about 11k, so that I've got room for headers in there as well. And then we're going to initialize our download slots using Jakub's function. We're then going to go in and do the download of each of the segments. So I've got a nice little request module that I'm using. That means I can just go and grab the segments one at a time. Fairly easy with the command request.get URL, and then I'm passing through some parameters into that, and they're just held in a map. So it's a really nice reusable HTTP GET service. I'm then going to do a bit of work calculating MD5s, just so that I can and printing those MD5s just so I can see what's going on and make sure that we're everything's going okay and that things are downloading correctly to the Pico. Really the important bit from a firmware write point of view is that we're going to write to flash for our chunk of segment of that we've just downloaded. So we've got our segment itself, where it is in an offset in memory, or should be an offset in memory, and what its length is. You'll notice I'm not doing any sanity checks to make sure that this is okay or right or anything. There are none of that in here at the moment, and I would expect there to be CRC and signature validation before you trigger a firmware update on your device. I haven't added those in. This is experimentation. So at this point we have the full firmware written into Flash. So I can finalize my MD5 across the whole of the data I've downloaded, the whole of the firmware, and just print that out. So I've got that MD5, and I can just confirm that against the file we were downloading manually as human, not computer doing that. Then we mark this download slot as being valid, so we've got a completely valid application, and we perform the update. And that's all there is to it, really. It's a really simple script. The other files you can see in the project are really about managing that request, that HTTP GET request, and my little library for handling that, and the TCP/IP transport and Wi-Fi management. So green, the green project is exactly the same in lots of senses, apart from I've cheated a bit and actually it includes none of the source code. So yes, I have downloaded the Pico firmware over OTA bootloader again and placed that there. But I haven't actually included any of this source code. As you all notice, there's no code in here at all. That's because we're nicking all the code out of the Blue project. And so there's really there's just make files sitting under here, enough to get this to build. And you'll see that we are placing in the release definition to be green and the new URL and a different GPIO pin for flashing this LED. Now, working with the firmware with this bootloader is a little bit more complicated because we've got two pieces of firmware and both need to be loaded onto the Pico to get us started. So first of all, we've built one for the Pico firmware OTA bootloader, and that's this ELF file here that we need to load that onto the Pico. And then we can load the actual application, which is the blue.elf for this version, which is in my build src folder. Now that then we'll start the process. Now when we get to the phase of downloading the firmware across HTTP GET, then we're using the .bin version of the firmware, which is so that we don't have to do any decompression or processing of the file once we receive it. We can load the bootloader and the app firmware onto the Pico using either the bootcell process or SWD. Jakub talks about using bootcell process and doing that in 2 steps onto the Pico, and it's great, that works. I didn't actually do that. I used SWD via OpenOCD to actually load the code on. Both processes work flawlessly though. And then once we've got both pieces of the firmware on, then we're on to the cycle, because Blue can go through and it can flash the LED and it can start the download and upgrade process, which then gets us into the green firmware being on there. Then we're into this automatic flashing and automatic update of the firmware as we go through our cycle. So in this demo on the blue screen you can see the output from the Pico, and you can see that that's running up with some new firmware, which is the blue firmware. And then the black screen on the side here is actually the output from our web server. So as this goes through its blue count and just approaches its update, you'll see it downloading the updates across to both the blue Pico output and the requests going through to the web server. Here we go, there we are. And I could actually check and see that all those MD5s match. And of course we should now get our Pico to be updating, and it should now become the green ID. And there we are, we're just booting up and we've got release green on there. And we will see that in a few seconds after we've picked up the IP address from the network, that actually we will start flashing the green LED. So this is that nice cycle working, and we're actually pulling down, as you can see, that firmware from my web server. Well, I hope you found that as interesting as I do. Certainly, I found that really fascinating, being able to get the updates to run straight to my Pico and actually run, switching back in between 2 different versions of the firmware. Now, of course, you wouldn't do that in reality. You'd be, updating it once a week, once a month, as bugs, etc. happen. But to be able to do that, it's great. There's, of course, more to do to this, to worry about. Actually CRC checking of what we're downloading. Is it actually a valid version? Did it actually come from me, or has someone else actually infiltrated my network and is now providing updates to my Pico-Ws? All of that stuff. We've talked about security before on the channel with Dr. Ian Oliver. All of that piece around integrity is really, really important when you start doing this sort of stuff. But just to be able to do it is really fun and really great bit of work. So thank you, Jakub, for your great work on that. Please do like the video and please do subscribe so that you stay updated. And I will see you next time. Bye-bye for now.